Bunsen burner is perhaps one of the most iconic symbols of chemistry. A Bunsen burner, just to remind you, consists of a small jet down here with two holes and a metal cylinder that you can rotate so that you can open and shut those holes. And the gas comes down the tube, up the jet, and air comes through these big holes, and the flame comes out at the top. If you look at a flame, you can see different parts are different colours. But most people just have to take their teacher or professor's word that some bits of the flame are hotter than others. With a thermal imaging camera, we can actually show you that this is true. And also, you can see more structure to the flame than you can with your eye. So Bunsen burners are usually used in two different modes. There's a mode where the air holes are covered up and you get quite a large yellow wavy flame. The yellow colour is from hot carbon particles which are radiating out heat. In the cooler mode, when you haven't got much air, the gas comes up and catches fire when it comes in contact with air. The heat of the flame generates carbon particles from incomplete combustion of the methane, which is in the gas, and eventually those particles burn. But the yellow colour of the flame comes from those carbon particles. When the holes are closed, the gas doesn't meet any air until it gets to the top. When we open the holes, we mix gas and air down here, and then they burn right at the top, and they burst into flames, and the flame is much hotter because the reaction is much faster. Now, the thing that intrigues me is that I've always been taught that the blue coloured cone that you see on the Bunsen burner ends at its tip at the hottest place in the flame. The truth is slightly more complicated than what I was told. There's all sorts of turbulence inside the flame and the hottest point moves around a bit. But I think why we were told keep whatever you're heating, particularly if you're trying to do glass blowing, if you keep the glass at the tip of the blue cone, you will be on average at the hottest point in the flame. It doesn't mean that any instant that is the hottest part. And for me, it is really very beautiful watching these flames, and to see how the temperature varies is really very nice. And what you can't see with your naked eye, but you can see really nicely with the camera, is the cool layer of air. It's not cold, but it's still quite hot, but much cooler, that is round the edge of the flame. The other thing is that it's nice to see how the heat moves down the Bunsen burner. Of course, most chemists know, or they learn by experience, that when you switch a Bunsen burner off, the top is hot. If you look at the way the Bunsen burner is constructed, you can see that there's actually a double layer of metal. I suspect the idea of that is to stop you burning your fingers quite so badly, but it still gets pretty hot. It must be said, and we'd explained this on our Bunsen burner video, that the burner was probably invented by Bunsen's technician, not by Bunsen. Professors in those days tended to take credit for their technician's work, but Bunsen himself apparently used to burn his fingers so badly that the skin was black and smoking when he was trying to do glass blowing.